So it all started with Newton sitting under an apple tree and pretending to be cool. A falling apple made him realize the existence of gravity. He formulated that gravitational force is proportional to the product of masses of the bodies. Newton claimed that the force pulling the apple to the ground and the force keeping the moon in orbit around the earth were actually one and the same. But this theory didn't explain how actually the gravity works. It just exists, that's all. Isaac Newton's first law of motion is an object remains in uniform motion unless acted on by a force. That means if you feel no force, you will either sit still or glide forever in a straight line at constant speed. Then comes Einstein. So what happens if this stick figure stepped off the roof? Weightlessness. It doesn't feel any force even as it accelerates toward the ground. So here's the paradox. An object that feels no force should travel at constant speed, but something accelerating because of gravity also feels no force. Einstein realized that if he resolves the paradox, he might explain the origins of gravity. The solution was that gravity is warp spacetime. Massive things like Earth warp spacetime. A freely falling object then follows the straightest possible path in spacetime. Consider this comic strip. If a man who has lived at sea level meets up with his twin who has lived in the mountains, he will find that his sibling is slightly older than him. And this is just the beginning. But it isn't only space that curves, time does too. Einstein predicted that time passes up more quickly high up than below. This was measured and turned out to be the case. This is all well and good when conditions are normal. However, in extreme cases like that of black holes, naked singularities, Big Bang theory, where energies are very high, we need a new theory of gravity, which is termed as quantum gravity. It is supposed to unify quantum mechanics and general relativity. We currently don't have a very satisfying model. At present, there are several approaches toward tackling the open question or writing quantum states of geometry. These include string theory and loop quantum gravity and others. Now, loop quantum gravity advocates a different perspective. The notion of a smooth, continuous background geometry is abandoned in favor of a discrete geometry which is built of elementary objects. These elementary objects are known as simplices, which is a complicated term for elementary geometric objects such as triangles and tetrahedra. Thanks for watching.